Why are there not more people talking about the incredible story of our planet's birth? Our journey begins 4.5 billion years ago, in the vast expanse of the cosmos. The solar system was a chaotic nursery of dust and gas, a swirling mass of potential. Gravity, the architect of the cosmos, pulled these particles together, orchestrating a cosmic dance. They swirled into a dense, incandescent disk, glowing with the heat of creation. At the disk's heart, a star ignited. Our sun, a beacon of light in the darkness. Around this nascent star, leftover material continued to coalesce, forming the building blocks of planets. These clumps grew larger, attracting more and more matter, becoming the seeds of future worlds. Eventually, these clumps became the planets, including our own Earth, a young world in the making. Early Earth was a molten inferno, bombarded by asteroids and comets, a fiery cauldron of creation. Volcanoes erupted, spewing lava and gases across the surface, shaping the land. This period of intense heat and bombardment shaped the young planet, forging its future. It laid the foundation for the world we know today, a world of incredible diversity and life. The atmosphere was thick with noxious gases, a toxic shroud over the young Earth. There were no oceans, no land, just a fiery, turbulent sphere, a world in turmoil. It was a hostile environment, unimaginable to us today, yet full of potential. Yet, within this chaos, the seeds of life were about to be sown, the first steps towards a living planet. This was the beginning of Earth's incredible story, a tale of transformation and life. Shortly after Earth's formation, a cataclysmic event occurred. A Mars-sized object named Theia collided with our young planet. The impact was colossal, sending debris hurtling into space. This debris, a mixture of Earth and Theia's remains, began to orbit our planet. Over time, gravity drew these fragments together. They coalesced, forming the celestial body we now know as the Moon. The Moon's formation had a profound impact on Earth. It stabilized Earth's axial tilt, creating a more stable climate. The tides, governed by the Moon's gravity, shaped the coastlines and influenced the evolution of life. The Moon also became a silent witness to Earth's transformation. It watched as oceans formed, life emerged, and continents shifted. Its gentle presence has been a constant throughout Earth's long and tumultuous history. It continues to inspire awe and wonder in all who gaze upon it. As Earth cooled, the once fiery and molten surface began to solidify, creating the first solid crust. Water vapor, which had been trapped in the thick atmosphere, began to condense and fall as rain, drenching the barren land. This relentless and heavy rain filled the numerous depressions in the Earth's crust, gradually forming the first oceans. These early oceans were a chemical soup, teeming with dissolved minerals and gases, creating a unique environment. They provided the perfect environment for life to emerge, with water acting as a catalyst for chemical reactions. The water acted as a solvent, facilitating essential chemical reactions that were crucial for the formation of life. It also shielded the nascent life forms from the harsh radiation of the sun, offering a protective cradle. The oceans became the cradle of life, nurturing the first living organisms in their depths. Within their depths, the first single-celled organisms appeared, marking the dawn of life on Earth. These simple life forms, though microscopic, were the ancestors of all living things on Earth, setting the stage for evolution. They began the long and complex process of evolution, gradually diversifying and adapting to their environment. The presence of water transformed Earth from a fiery wasteland into a vibrant, dynamic world, teeming with potential for life. The oceans, teeming with life, became the dominant feature of our planet, shaping its future. They continue to play a vital role in regulating Earth's climate and supporting the incredible diversity of life, from the smallest plankton to the largest whales. In the depths of the oceans, around hydrothermal vents, life began to stir. These vents, spewing hot, mineral-rich water, provided the energy and nutrients for the first organisms. These were simple, single-celled prokaryotes lacking a nucleus. These early life forms were extremophiles, thriving in extreme conditions. They were adapted to the heat, pressure, and chemical composition of the vent environment. They obtained energy through chemosynthesis, converting chemicals into energy. Over millions of years, these simple organisms evolved. They diversified, adapting to different environments. Photosynthesis, the process of converting sunlight into energy, emerged. This revolutionary process transformed the Earth's atmosphere. The emergence of life was a pivotal moment in Earth's history. It marked the beginning of a new era, one dominated by the interplay between life and the environment. Life began to shape the planet, influencing the atmosphere, oceans and land. Section 5. Oxygen's ascent, a toxic transformation. Around 2.4 billion years ago, cyanobacteria, also known as blue-green algae, evolved. These tiny yet powerful organisms began to change the world in ways unimaginable. These microscopic organisms were the first to perform oxygenic photosynthesis, a process that would forever alter the course of Earth's history. They used sunlight, water and carbon dioxide to produce energy, releasing oxygen as a byproduct. This seemingly simple process had profound implications. This release of oxygen had a dramatic impact on Earth's atmosphere, gradually increasing the oxygen levels in the air and water. Oxygen was toxic to most existing life forms at the time, which were adapted to an anaerobic environment. This led to a mass extinction event known as the Great Oxidation Event, wiping out a significant portion of Earth's anaerobic inhabitants. It drastically altered the composition of the atmosphere, making it richer in oxygen and setting the stage for new forms of life. The rise of oxygen paved the way for the evolution of more complex life forms, allowing for greater biological diversity. Aerobic respiration, using oxygen to produce energy, is much more efficient than anaerobic respiration, providing a significant evolutionary advantage. This allowed organisms to grow larger and more complex, leading to the development of multicellular life and eventually the vast array of species we see today. The Great Oxidation Event was a turning point in Earth's history, marking the transition from a world dominated by simple anaerobic life forms to one teeming with complex aerobic organisms. It transformed the atmosphere, paving the way for the evolution of life as we know it, and demonstrating the profound impact that life can have on the planet. It was a testament to the power of life to shape the planet, illustrating the dynamic interplay between living organisms and their environment. Section 6. Snowball Earth, a frozen embrace. Between 720 and 635 million years ago, Earth experienced a series of extreme ice ages. Glaciers advanced from the poles, covering much of the planet in ice. This period is known as Snowball Earth. The causes of Snowball Earth are still debated. One theory suggests a decrease in atmospheric greenhouse gases. Another proposes changes in Earth's orbit or the continent's position. Regardless of the cause, the effects were dramatic. Life persisted during Snowball Earth, finding refuge in areas where liquid water remained. These refugia, perhaps around hydrothermal vents or beneath the ice, allowed life to survive the harsh conditions. The end of Snowball Earth was marked by a rapid warming. Volcanic eruptions released greenhouse gases, trapping heat and melting the ice. This led to a dramatic increase in atmospheric oxygen, setting the stage for the Cambrian explosion. Section 7. Cambrian Canvas. Life explodes. Around 540 million years ago, the Cambrian explosion occurred. This period saw a rapid diversification of life forms. New body plans, complex structures, and evolutionary innovations emerged. The oceans teemed with a variety of new creatures. Trilobites, with their segmented bodies and hard shells, became abundant. Sponges, jellyfish, and worms also flourished. The fossil record from this period reveals a sudden burst of evolutionary creativity. The Cambrian explosion is considered one of the most important events in the history of life. It established the basic body plans for many animal groups that exist today. It marked a dramatic increase in the complexity and diversity of life on Earth. The drivers of the Cambrian explosion are still being investigated. Increased oxygen levels, changes in ocean chemistry, and the evolution of predator-prey relationships are all thought to have played a role. It was a period of rapid evolutionary experimentation and innovation. Section 8. terrestrial pioneers conquering the land. Around 470 million years ago, life began to colonize the land. Plants were the first pioneers, establishing themselves along the shorelines. They evolved adaptations to survive the harsh conditions, including roots to absorb water and nutrients, and a waxy cuticle to prevent water loss. Following the plants, animals also began to venture onto land. Arthropods, such as insects and millipedes, were among the first. They evolved exoskeletons to provide support and protection from the dry air. Amphibians, evolving from fish, followed later. The colonization of land was a major step in the evolution of life. It opened up new habitats and opportunities for diversification. The land became a new frontier for life to explore and conquer. The movement of life onto land also had a profound impact on the planet. Plants helped to stabilize the soil, preventing erosion. They also began to influence the climate, absorbing carbon dioxide and releasing oxygen.